Okay, so we're looking at Minitest week 28, and this is question 2. So I've got the mass of particle P, and I'm told that there's a force of capital F, and to come on to that in part B, and then I'm given a function for the velocity. So I'm given velocity as a vector, and it's also a function of time, and then I'm asked for the acceleration. And I'm asked the acceleration at t seconds, so I'm not after an actual value here, I'm just basically after the acceleration in terms of t. So if I've got velocity and I want the acceleration is the differential of velocity, and I can just differentiate the coefficient of I and j separately. So 3t squared is going to differentiate to 6t, and 1 minus 4t is just going to differentiate to 4. So there we go. So that's part A. Okay, so then for part B, they wanted the magnitude of the force at 2 seconds. So I can find the acceleration at t is 2. So when t is 2, so I'm just going to go back and substitute t is 2 into this. So if t is 2, that's going to be 12i minus 4j. Okay, and then they wanted, so what did they want? They wanted the magnitude of the force. So I can get the force, I could just get the magnitude of the acceleration and then use that, but let's keep it in vector form and use F equals ma. So whenever I'm doing arithmetic with vectors, I prefer to work as column vectors, but you don't have to do that. So however you prefer to lay out is fine. So if we go back to the question, so we were told the mass is 0.5. So that's going to be 0.5 times acceleration. So I'm just doing acceleration as a column vector. So the force is 6 minus 2, and then always just read it really carefully. So if it had just asked me for the force, then that would be my final answer, but it wants the magnitude of the force. So magnitude of any vector is just Pythagoras. So the magnitude of the force is going to be 6, square root of 6 squared minus 2 squared. So root 40, just go to the calculator. So 6.32 newtons to 3 significant figures.